Alright, hello everybody. We just took our test on our first unit of trig. Our next unit is also going to be on trig. So this unit 5 is going to be based off of a continuation of trig. Now back in unit 4 we learned about sine, cosine, and tangent. There are actually 6 trig functions that we work with normally in trig. Okay, so we got sine, cosine, and tangent, but we also have 3 other functions. So let's just take let's just take a quick little review of the 3 functions that we've worked with. All right, so our 3, and I'm going to call these the 3 main ratios, trig ratios. Okay. All right, we have our sine, and that is abbreviated as sin. And we know that the sine of our angle is equal to the ratio of the opposite side over the hypotenuse. Then we had our cosine function, and that is abbreviated as cos. So the cosine of our angle, that ratio is adjacent over hypotenuse. All right, and then finally we wrapped it up with the tangent, which is abbreviated as tan. So the tangent of our angle is equal to the opposite side over the adjacent side. And our little saying that we've always used to remember these ratios was so, ka, toa. The sine is equal to the opposite over the hypotenuse. The cosine is equal to the adjacent side over the hypotenuse. And the tangent is equal to the opposite side over the adjacent side. Okay, so just as a quick little refresher, let's draw this right triangle in real quick. Alright, so some of you struggled a little bit with opposite and adjacent. We all kind of figured out what the hypotenuse was. The hypotenuse was always like the slanted side, the side that was not the right angle side. Okay. I suggested that when you have your triangle, you highlight the angle that you're working with. Okay. So the side that is not highlighted is going to be the opposite side. So here's your angle directly across, or directly opposite is the opposite side. So this is your opposite side. This is opposite of the right angle, so this is the hypotenuse. And remember, adjacent means beside, so this is the side beside the angle, so that's the adjacent side. Alright, so sine, cosine, and tangent are our 3 main ratios that we work with a lot of times. But we also have 3 other ratios, and these are called the reciprocal ratios. The reciprocal ratios. Now, as you're copying that down, think about what reciprocal means. Reciprocal means you, as y'all like to say, you flip it. Okay? Well, that's kind of what we're going to do with these ratios. We're going to flip them. Okay. All right. The reciprocal function of sine is cosecant, and that is abbreviated as CSC. Okay. Alright, so if the sine was opposite over hypotenuse, then the cosecant is hypotenuse over opposite. The reciprocal of cosine is secant. That is abbreviated as SEC. All right. If cosine is adjacent over hypotenuse, secant, taking the reciprocal of this, is going to be the hypotenuse over the adjacent. Now, yes, ever since I've been teaching math, I've always thought, why didn't they just make the reciprocal of sine be secant and the reciprocal of cosine be cosecant? Because then that way the c's would match up and the s's would match up. I have no idea why they did that, but they just did it. All right, and then, like, especially when you see the reciprocal of tangent. The reciprocal of tangent is cotangent. So at least you can tell cotangent is going to go with tangent. And the abbreviation for that is COT. And the cotangent, and I should be putting the angle symbol here. The cotangent of your angle, well, if tangent is opposite over adjacent, the reciprocal of that would be adjacent over opposite. Now, if we use the first letter of each one of these to create our little cheesy saying, let's see what we have. We've got a C, H, O, so cho, S, H, A, sha, cho sha, and then C, A, O, cho sha, ko, cho sha, ko. Alright, so in our first example here, we're going to be asked to find the exact value of the trig function. And for this set of problems, more than likely we're going to have to use our Pythagorean theorem. So find the value of the trig function, or the exact value. Now, as you're copying this down, if you notice in the diagram, you're only given two sides. So depending on what trig function they're asking us to find, we may have to use the Pythagorean theorem. We might not have to use the Pythagorean theorem. And the reason why I know that we may have to use the Pythagorean theorem is because we're given two sides of a right triangle. And anytime we're given two sides of a right triangle, we can use the Pythagorean theorem to find that missing side. I'm going to highlight the angle that I'm working with. Alright, secant. We know that the secant is the hypotenuse over the adjacent, so it's our ha. Okay, so do I know my hypotenuse? I do not know the hypotenuse, so I'm going to have to find the hypotenuse. Do I know my adjacent? Alright, well, remember, when you highlight the angle, the adjacent and the hypotenuse make up the angle. So I know that my adjacent side is 15. So now I've got to find my hypotenuse. Okay, so we're going to come right here and use Pythagorean theorem. Alright, we've got 8 squared plus 15 squared is equal to c squared, our hypotenuse. So we got 64 plus what, 225 equals c squared. Let's see, let's add these together. That's going to give us what? 289 equals c squared. So taking the square root of each side of these, the square root of 289 is 17. So our missing hypotenuse is 17. So right here in place of h, we're going to put 17. Now notice I didn't use any trig in the calculator. They're not asking you to find the angle, they just want you to find the ratio of the sides. Okay. Alright, so let me give you an example that's very similar to example A. In fact, I'll make this pretty easy. Well, yeah, I will make this one easy for you. I'm going to go ahead and just give you the sides. Alright, find the secant of theta for me. Alright, about 20 more seconds. Alright, so let's see how you did. Alright, the secant we know is equal to the hypotenuse over the adjacent. So here our hypotenuse is 13. Our adjacent is 12, so we get 13 over 12. And there we go. So when they are asking for the exact value, you don't change it to a decimal, you leave it as a fraction. Alright, so once again, I'm going to give you all three sides. So I'll give you a few seconds to copy this down, and then we'll find the cotangent. Alright, so the cotangent we know is the adjacent over the opposite. So here's my angle. This side right here is the hypotenuse. This side right here is the adjacent. So I need the adjacent side. And then this side is the opposite. So I need the opposite side. So the adjacent is 4. The opposite is 3. So I get 4/3. Alright, so let's go ahead and copy down these last three, and then we'll come in here and work these together. Alright, so take about a minute, copy these down. Alright, now as you finish copying down this during these last few seconds, alright, we've got Unit 6, which is the second half of our trig, Unit 5, which is the second half of our trig functions. And then we're going to have Unit 6, which is on finding prediction equations, okay, or regression equations. Okay, and then that will be it. And then we got our exam. We're almost at the end, y'all. This semester has flown by. All right, so let's come in here and look at these three problems here. All right, let's say in D, they asked us to find the cosecant of theta. All right, so cosecant is equal to the hypotenuse over the opposite. All right, so here we got the hypotenuse is 17. Our opposite side, directly across from our angle, is the opposite. So we get over 15. So 17 over 15 is our answer for D. All right, let's say for E, they also asked us to find the cosecant of theta. Well, once again, the cosecant of theta is hypotenuse over opposite. All right, so hypotenuse is 24. The opposite is 16 over the square root of 2. Now, we know we're not allowed to have a radical in the denominator, so we need to rationalize. But before I rationalize, I'm going to go ahead and reduce as much as I can so that I don't have to work with such large numbers. All right, 8 is the GCF of 24 and 16. So let's go ahead and simplify this. 8 goes into 24 3 times. 8 goes in 16 2, so we get 2 onto the square root of 2. And remember, when you rationalize, you multiply the top and the bottom by whatever your denominator is. So we're going to multiply the top and bottom, your numerator and your denominator, by 2 times the square root of 2. All right, whole number times whole number. So 3 times 2 gives us 6 onto the square root of 2. 2 times 2, this 2 times this 2 gives me 4. This 2 times this 2 gives me 4 as well. All right, but we know right here the square root of 4 is 2. So what we have is 4 times 2, which is 8. So we get 6 times the square root of 2 over 8. And then finally reducing one more time. 2 goes into 6 3 times. And 2 into 8 is 4. So finally, 3 times the square root of 2 is 4. Sometimes that rationalization takes forever, like right here as we saw. All right, for F, let's say they asked us to find the cotangent of theta. All right, cotangent is the adjacent over the opposite. All right, so the adjacent, all right, this side is the hypotenuse, this side is the adjacent. So we get 2 times the square root of 5. The opposite, directly across from your angle, is 4. We don't have to rationalize because the radical is in the numerator, and it's okay to have it there. But I do need to simplify 2 over 4. 2 goes into 2 one time. 2 into 4 is 2. So we get the square root of 5 over 2. All right, moving along, example 2. Alright, so here in example 2, they're asking us to find the value of the trig function given a trig function. Okay, so in example 1, we were given the triangle, we were given the lengths of the sides of the triangle. Sometimes we were given all 3 sides, so that was good. We didn't have to do any work other than the ratio. But sometimes we were given only 2 sides and we had to use the Pythagorean theorem. But for this one, they're going to take it a step further. Okay, they're going to give you a trig ratio and they're going to ask you to find a different trig ratio. And that makes a whole lot of sense, right? So, they're going to ask us to find the cosecant of theta if the tangent of theta is equal to 3 over 4. Alright, so notice I didn't give you a diagram. We know that we're working with right triangles, so what you're going to do is you're just going to draw a right triangle. So drawing our right triangle, and let's pick this one to be theta. Alright, what they are giving us here is tangent. And we know tangent is opposite side over the adjacent. So they are giving you the lengths of these sides. So they're telling you the opposite side is 3, and they're telling us the adjacent side is 4. And now they want us to find the cosecant. All right. Alright, so the cosecant is the hypotenuse over the opposite. Alright, we don't know the hypotenuse, but we do know the opposite. The opposite is 3, so we know our denominator is going to be 3. So we've got to come in here and we've got to find the missing side. So we're going to have to use the Pythagorean theorem. Okay, so we got 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 9 and 16 give us 25 equals c squared. So when we take the square root, we get c equals 5. So here our hypotenuse is 5. Alright, so try this one. This one should be a pretty easy one. Find the tangent of theta if the sine of theta is 4 over 5. So draw your right triangle, label your sides, find the missing side if you need it using Pythagorean theorem, and then find the tangent of theta. So if you'll pause the video right here for about 2 minutes. Okay, so we got the sine of theta is 4 over 5. Well, we know sine is opposite over hypotenuse. So they're telling us that our opposite side here is 4 and that our hypotenuse is 5. Well, if you notice, we kind of got a 4 and a 5, so we kind of know that this side is going to be 3, but let's see if we even need it. Tangent of your angle is opposite over adjacent. So we definitely do need the adjacent. So right here, I would come right here and I would say 4 squared plus b squared equals 5 squared. We get 16 plus b squared equals 25. Subtracting that 16, we would get b squared equals 9. So then we get b equals 3. So the missing side is 3 here. All right, so our opposite side is 4. Our adjacent side is 3. Now, since they are only giving you 2 sides, more than likely for all the problems, you'll always have to use Pythagorean theorem. Not unless they were like given the cosecant, what is the sine? Because they're reciprocal, so then all you would have to do is just flip this right here. And so we're taking baby steps. So let's move into a problem that might be a little bit more difficult. All right, find the secant of theta if the sine of theta is equal to 3 times the square root of 13 over 13. All right, so again, we're going to draw our triangle. All right, so the sine I know is opposite over hypotenuse. So our hypotenuse is 13, and the opposite side from the angle is 3 times the square root of 13. Looking for a secant. All right, so remember, Cho, Sha, KO. All right, so the secant is hypotenuse over the adjacent. All right, well, we got the hypotenuse, that's 13, but we don't have the adjacent. We're missing the adjacent side. So we've got to use Pythagorean theorem to find the adjacent side. So let's see. We've got 3 onto the square root of 13 squared plus b squared is equal to our hypotenuse squared. All right, right here, 3 times the square root of 13 squared. Now you can put it in Desmos just like that to get your output. But think about what this means. This means 3 times the square root of 13 times 3 times the square root of 13. So we would say whole number times whole number. So 3 times 3 is 9. And then we say radicand times radicand. 13 times 13 is 169. But the square root of 169 is 13. So we end up with 9 times 13, which is 117. And 13 squared is 169. So subtracting 117 from both sides, we get b squared equals 52. Taking the square root, 52 is not a perfect square. But I'm going to ask myself, can I reduce 52? All right, so we got 52 is 1 and 52, 2 and 27, 3 can't go into it, but 4 can go into it. 1, 3, 5 is a no, 6, 7, 8, 9, 10, 11, 12. All right, so those are our only factors. Notice here 4 is a perfect square. So we can break 52 down into 4 times 13. When you're trying to simplify a radical, you always want to try to break it down into a perfect square times a number. And if it's more than one perfect square, you always choose the largest perfect square. So the square root of 4 is 2, so it's going to come out as a 2. And then this stays the square root of 13. So finally, we've got this as 2 times the square root of 13. All right, so our denominator, which is our adjacent side, is 2 onto the square root of 13. And yes, we've got a radical in that denominator, so guess what we got to do? We got to rationalize. Yes, this is the forever problem, seems like. It's going to go on and on and on. So let's rationalize this. We got 13 times 2 in the square root of 13. So we're going to multiply the numerator by 2 in the square root of 13 and the denominator by 2 in the square root of 13. All right. 13 times 2 is 26. 2 times 2 is 4. 13 times 13 is 169, but then the square root of 169 is 13. So basically when you square a square root, remember, the radical goes away. So let's see, 4 times 13, 4 times 3 is what, 12. So we get 26 over 52. And the GCF is going to be 26. 26 goes into 26 one time, so we'll get the square root of 13. 26 into 52 is 2. And finally, after all of that, we get square root of 13 over 2. That was a doozy, for sure. Now, most of the problems that you'll have will be as easy as A and B. Every once in a while, I might sneak one of these in here. So, make sure that if you get a problem like this, you look back to your notes. Don't let the notes just be something you write down. When you take notes as a reference, you reference back to them to see if you see an example that will guide you into how to solve the problem that you are currently working on. All right, finishing up with example 3. Find the trig ratio for a given point. All right, so for these problems, we're going to be using the coordinate plane. All right, so here we're given that the point negative 21, 20, and they want us to find the secant of theta. So notice they don't give us a diagram. All right, so there are a couple of steps that we want to do. Okay, the first thing we're going to do is we're going to determine what quadrant. So determine the quadrant that your point lies in. Does it lie in quadrant 1, 2, 3, or 4? All right, and then we're going to label the X and Y lengths. And then the Pythagorean theorem is going to sneak back in. And then we're going to write our trig ratio. All right, so just as a refresher about our quadrants, quadrant 1 is positive, positive. Quadrant 2, the signs are negative, positive. Quadrant 3, the signs are negative, negative. And quadrant 4, your signs are positive, negative. And I gave you a little cheesy saying back in Unit 4. I said, all students take classes. Now what this little cheesy saying means is that here in quadrant 1, all your signs are positive. All the trig ratios are positive. So all trig ratios are positive. All right, students. All right, student starts with S. The sine and its reciprocal, which is what? What's the reciprocal? Right, cosecant. These are the only ones that are positive in quadrant 2. Everything else would be a negative. So like tangent and cotangent would be negative, and then your cosine and secant would be a negative. All right, take. Take starts with T. Your tangent and cotangent are positive in quadrant 3. Everything else would be negative. So sine, cosecant, cosine, and secant would be negative in quadrant 3. And then classes starts with a C, so that is your cosine and its reciprocal of secant. Those will be the only positive trig ratios in quadrant 4. All the other trig ratios would be a negative value. And those would be sine and cosecant, tangent and cotangent. Alright, so let's get started on part A. Alright, so what you're going to do is you're going to draw yourself a little quadrant. And then ask yourself, what quadrant does this point fall in? Well, we got our x and our y is negative, positive. So negative, positive would be quadrant 2. So we're going to put a point right here and then draw in a right triangle. Your reference angle serves as theta. So we determine the quadrant, and now we want to label the x and y lengths. Alright, so your x, this is your x-axis. Your x length is negative 21. So that's your x. And our y, this is our y-axis. Our y is 20. And they are asking us to find the secant of theta. Alright, and we know that secant is equal to, alright, so again, let's write our little saying just so we can remember it. Alright, so what's our saying? Cho, sha, ko. The secant is equal to the hypotenuse over the adjacent. In looking at our right triangle right here, we see that we're missing the hypotenuse. So we're going to have to use the Pythagorean theorem to find that hypotenuse. So coming right here, we're going to have a squared plus b squared equals c squared. All right, 20 squared is 400. 21, negative 21 times negative 21, I believe is 441. When we add those together, we get 841 is equal to c squared. Taking the square root, c equals 29. Alright, so now we've got our adjacent and our hypotenuse. So the hypotenuse, oops, come back here, pen. The hypotenuse is 29. The adjacent is negative 21. So the secant of theta is negative 29 over 21. Alright, let's try one more together, and then I'll give you one to try on your own, and then we'll be done. So given 7,3, find the secant of theta. Alright, so going through our steps, we need to determine what quadrant that's going to be in. So remember, this is your x and y. It's positive, positive, which is going to be the first quadrant. So we're going to put our point right here and draw in our right triangle. That reference angle is going to be your theta. All right, our x is 7, our y is 3, and they want the secant, and we know the secant is the hypotenuse over the adjacent. So once again, we're going to have to use Pythagorean theorem. Alright, so we got 3 squared plus 7 squared equals c squared. So 9 plus 49 equals c squared. We get 58 equals c squared, taking the square root. We get c equals the square root of 58. So here the hypotenuse is square root of 58. Now 58 does not have any perfect squares for its factors, but let's just test and see to make sure. 1 and 58, 2 and 29, 3 can't go into it, 4 can't go into it, 5, 6 can't go into it, 7, 8 can go into it, 9 can't. Okay, so we're pretty much, you can go through it all, but that's it. There's no perfect square, so we just leave it like that. Alright, so let's see, the secant, the hypotenuse is the square root of 58, and the adjacent is 7. It's okay to have a radical in the numerator, so we're done. And the secant is supposed to be positive in the first quadrant because everything's positive, and we do have a positive. Alright, our last one. So you try. Alright. Given the point -12, -5, find the cotangent of theta. So if you'll pause the video here for about 2 to 3 minutes and work through that. Alright, so let's see how you did. Alright, I see I've got negative, negative, which is going to be in quadrant 3. So I'm going to go ahead and draw my right triangle in quadrant 3. Okay. Your x is -12. Your y is -5. Cotangent. Alright, if tangent is opposite over adjacent, cotangent is going to be adjacent over opposite. And if you notice, we've got the adjacent and we've got the opposite. So we don't have to use Pythagorean theorem here, do we? Alright, so here the adjacent is -12, the opposite is -5, and that's going to reduce to 12 over 5. And there we go. Now, just in case you didn't take notice that you didn't have to find the hypotenuse, when you found the hypotenuse, you would have got a 13. But we didn't need that. So, alright, that was it. We are done. So if you make sure your name and date are on your notes and submit the notes.